All right, we're going to start our new unit of verifying trig functions using identities and solving trig functions using those identities as well. In order to do that, we're going to start with this formula chart here to show you all of the different identities. Some of these you will have to learn, and some of them you will be given during quizzes and tests on a formula chart. So when we start looking at this right here, and all of the identities are listed on this page just as a starting point where we're going to start teaching you. So reciprocal identities, and most of these you should already know because we did talk about them in the last unit, like sine of theta equals 1 over the cosecant of theta, and cosecant is 1 over sine, and so on. Those you should know, so you want to learn those. The quotient identities, which is tangent of theta is equal to sine of theta over cosine of theta, and cotangent is equal to cosine over sine. Those are some that you have to know as well, those quotient identities. And the Pythagorean identities are also something that you need to know. Sine squared of theta plus cosine squared of theta is 1. This is one that we will use very, very often, probably the most important one you have to learn. Then 1 plus tangent squared of theta equals secant squared of theta, and cotangent squared of theta plus 1 equals cosecant squared of theta. So those are all required to learn, and as you practice them, you're going to memorize them as you're practicing them, but those are the ones that you really want to study and learn. There are other identities that you see here, the cofunction identities, the even and odd identities, the sum and difference identities, and the double angle identities. We will go through all of those as we go through the unit, but those are the ones that will be given to you. So we're not going to expect you to memorize those. You'll be given them in a formula chart. All right, so let's start working with those so that you see what we use them for. They're used to simplify or simplify in solving. And so to do that, we're going to talk about a couple of them, especially the ones that you have to learn. Those are the ones we're going to start with first. So cosecant of u is equal to 1 over sine of u. That's one that you should know. That is the same thing as sine of u is equal to 1 over the cosecant of u. So both of those you should be able to work back and forth between those. Same thing with the secant of u and cosine. That means the cosine of u is equal to 1 over the secant of u. And for the cotangent, then tangent of u is equal to 1 over the cotangent of u. Those are the ones that you're going to have to be able to recognize and recognize quickly. Now, there are some other versions of that that you'll also have to recognize. For example, if we had 5 secant of u, that is the same thing as 5 over cosine of u. Whole numbers are over 1, so that 5 would stay in our numerator, and the cosine of u is what would come out to the denominator. So you have to be able to recognize it with a constant like that. Another thing that you'll see often is with a negative sign. So for example, if we had negative tangent of u, that is the same thing as negative 1 over cotangent of u. So you've got to recognize it with the negative signs as well. So there's a couple different ways that you'll see those. For tangent of u equals sine of u, if you remember the unit circle, we always said sine was y and cosine is x. So that's where this identity comes from. Since y is sine and x is cosine, then the tangent of u has to be sine of u over cosine of u. And since the cotangent of u is the reciprocal, or x over y, that's where we get this identity. There's another version that you can also, just like we did up there, there's other ways that you'll see it as you're simplifying. For example, the tangent squared of u. That is the same thing as sine squared of u over cosine squared of u. It's the same one. Both of those are the same. What looks different is that square. Since this one was square, both of those are squared. That's an identity you'll have to be able to recognize as we work through them. All right, for our Pythagorean identities, that comes from, remember Pythagorean is a squared plus b squared equals c squared. Well, in the unit circle, the radius is 1 and 1 squared is 1. One side of it is the x and the other side is y. So that's where that x squared plus y squared equals 1. So that's where these are coming from. Because sine is y, that's y squared, and cosine is x, so that's x squared is equal to 1. That's where this identity comes from. Again, you should recognize it when it's manipulated as well. So if we subtracted this sine squared to get it to the other side, we would get cosine squared of u is equal to 1 minus the sine squared of u. You'll use this often. Sometimes they give you this portion of it and you need to know that's cosine squared of u. The better you know these, the easier it is for you to see them when they're manipulated. Obviously, another manipulation would be if you subtracted the cosine to get it to the other side. So sine squared of u is equal to 1 minus the cosine squared of u. So those are two that you'll see often. Same thing with this one. I can subtract that 1 to get it to the other side, and I get tangent squared of u is equal to secant squared of u minus 1. This is one that you see often, so make sure that you're able to recognize that one. And if we subtracted that tan to get it to the other side, then 1 would be equal to secant squared of u minus tangent squared of u. For our last one here, if I subtracted, oops, I wrote cosine. If I subtracted the 1 to get it to the other side, I would get cosecant squared of u minus 1. So that's another way of manipulating that. Another option is to subtract the cotangent. So 1 is equal to cosecant squared of u minus cotangent squared of u. So those are two, some of the options. Obviously, you can manipulate it other ways. So you want to make sure that you know what these first identities are so that you can recognize those that are manipulated. All right, so we're going to start to identify some of these identities and use them to simplify. So this one that we've got here, sine of x minus sine of x times cosine squared of x. The first thing we would want to do is factor. So we had you practice that factoring so that you were ready for this. We've got a sine of x on both of these, so we can factor out a sine x. And so sine of x times 1 gives me the sine of x, and sine of x times the negative cosine squared of x gives me the second term. And then this is one of the identities that we can recognize. It's right here, 1 minus cosine squared of u is equal to sine squared. So this is sine of x times sine squared of x, which gives us the sine cubed of x. So we just used those identities to take it down from a more complicated one to an easier one to look at, something that's a little bit simpler. All right, for the second one, we've got secant squared of theta minus 1. That's one of the ones that we manipulated over here that we said we need to know. So secant squared of u minus 1 is tangent squared of u. So tangent squared of theta. I simplified using that identity. All right, so on this one here, the first thing I want to do is I want to rewrite that cotangent of t to be the cosine of t over the sine of t times the cosine of t. So cotangent of t is the same thing as cosine over sine. So I rewrote that. When I'm multiplying here, I end up with sine of t plus cosine squared of t over sine of t. At this point, you need to remember some of the stuff from way back when we worked with rationals. In order to put these two together, because there's an addition, we have to have a common denominator. So I would get a common denominator of sine t. So I multiply sine times the top and sine times the bottom. Now they have a common denominator. And so I keep the denominator and I add my numerator. Well, sine squared plus cosine squared, sine squared plus cosine is 1. So this is 1 over sine, which we know to be cosecant. That one took a couple more steps than we probably wanted to do, but it was from this harder portion to just cosecant of t. So that is a more simpler term for this identity. All right, for number 4, we have 4 tan squared of u plus tan u minus 3. This is one where, again, you have to recognize that as a factoring. So we had you factor earlier on as a warm-up. I'm going to go ahead and write what the factored form would look like here without the tangents. It's the same thing as 4x squared plus x minus 3. That means you would want to use a box or slide and divide or whatever method you use to factor. And so this factors to be 4x minus 3 and x plus 1. That means that the factors for this would be 4 tangent of u minus 3 tangent of u plus 1. That's as far as we can go. There's no identity that can take us any further, so the factored form is the simplest form on that one. All right, so there's some more back here now that we're going to look at. We are going to keep going with some of the factoring theme here, but we're going to throw in some identities as well to help you. So cosecant squared of x minus cotangent x minus 3. In this case, I need to recognize that the cosecant squared of x is 1 plus the cotangent squared of x, because then I'll have the same terms. So cosecant squared, I recognize that that needs to be changed, and I need something with a cotangent in order for that to work. So cotangent x minus 3. All I did was replace just that part. Now I can combine my like terms, and I get cotangent squared minus cotangent of x minus 2. Now that we have the trinomial, this is something that factors. So I'll go ahead off to the side again. That's the same thing as x squared minus x minus 2. This is something you should be able to factor. To get x squared, we know that's x times x. And then we're looking for what multiplies to be negative 2 and adds to be negative 1. And that is negative 2 and a positive 1. And so to factor this, that's going to be cotangent of x minus 2, cotangent of x plus 1. So now we've got our factored form there. All right, for our number 6 here, this one you have to recognize up in the top. Remember when we were factoring the difference of two squares? That's one that we said you need to be able to recognize often, difference of squares. And so that anytime we have a squared term minus a squared term, it is the first term minus the second. So cosine x is what's being multiplied here, and 2 is what's being squared there. And then we get cosine x plus 2. So that is our numerator. Our denominator stays as cosine x minus 2. We've got this in both the numerator and the denominator. So the cosine and the cosine cancel. We're left with cosine x plus 2. Some of these are complicated. Sometimes you're going to start one way and realize that that's not going to help you simplify. And so you've got to erase and start. That's just part of it. It's kind of like a puzzle putting these all together. We always say you want a big eraser and a lot of paper for this unit, because as you get started, it's not always going to be the best plan, and you're going to have to go back and erase and start with a new plan. And there's not always one way to go about it. So you're going to have to really get in there and work them is really the best way of doing it. All right. So on this second one here, or sorry, number 7, we're going to keep our cosine squared of x. And we're going to go ahead and rewrite this tangent squared of x. Remember, that is the same thing as sine squared over cosine squared. Tangent of squared x is the same thing as sine squared of x over cosine squared of x. That means that these two are going to cancel out. Since 1 is in the numerator and any whole numbers over 1, so 1's in the numerator, denominator, they cancel out. So we get cosine squared of x plus sine squared of x. And we recognize this identity as 1. So that is way simpler than what we started with. And that's always our goal, is to get this to the simplest form. All right, number 8 is one that's a little bit harder. We're going to have to get a common denominator here to get these to do something. So we've got to get a common denominator between these two. Well, the only denominator that's going to work for both of those is going to be the sine theta and 1 plus cosine of theta. So we need them both to have this denominator. We learned that back in rationals, you get the common denominator in order to be able to add the two together. Now to get from this first denominator to this new one, we multiply times sine theta. So I need to do the same thing to the numerator. So that gives us sine squared of theta. On the top, to get from this denominator to this new one, we multiplied times 1 plus the cosine of theta. Now we keep the denominator, so I'm going to keep the sine of theta times 1 plus the cosine of theta. For our numerators here, I'm going to distribute this as I put it together. So I get sine squared of theta plus cosine theta times 1 is cosine theta. And then cosine theta times cosine theta is cosine squared of theta. All right, in order to simplify this now, we have a sine squared of theta and a cosine squared of theta. And remember that sine squared of theta plus cosine squared of theta is 1. So we get 1 plus the cosine of theta. And when we get to this point, we have a 1 plus cosine of theta and a 1 plus cosine of theta, so they cancel out. That gives us 1 over the sine of theta, and 1 over sine of theta you should recognize as cosecant of theta. So that's another one that was a little bit harder. It had a lot more steps. Again, for when you're starting, sometimes you're going to make a mistake when you're moving along. You think one way is a better way to do it. So make sure that you're practicing these. I'm going to write out here to the side, the sine squared theta plus cosine squared theta was equal to 1. That's what we used to get that right there. All right, so today we've just shown you some of the identities. Remember, these are the ones that you have to have memorized or learned, however you want to think about it. Make sure that you're practicing through them so that you get comfortable with them.